What is going on, everybody? Episode 3 of the Tree of Trust. And I've got two of my favorite people here today. They were kind of pretentious and put doctor in front of the name. I feel like I messed up here. Anyway, we got Dr. Travis Wyman and Dr. Ben Morrill. How are y'all doing today?
They called you Dr. Pat on another episode. We can go.
You know what? They do call me Dr. Pat more than I'd like, but that's okay. Quick side note there. It's funny because I actually hate being called Pat with an undying passion, but it's just become so prevalent at this point that I just have to accept it. So here we are.
Hey, I'm kind of the more I hate being called doctor with a passion. Like people call me Dr. Wyman and I'm like, who the fuck are, you're talking about me. But again, it has become so much a thing that everybody else is like Dr. Wyman, Doc Wyman. So it's like, I just have to embrace it.
Yeah, I just stopped putting it with anything because no one ever seemed to care. And the one time that I was like, I'm going to put doctor or PhD on something was at the airport. And turns out Delta adds PhD to the end of your name, which then, of course, makes your name incorrect because my name is not spelt McKnight PhD. Exactly. And so that turned into a whole ordeal. And I was like, this is me being punished for trying to be doctor. Okay, I get this now. So it's good stuff. Good stuff. So how Travis, how's your week been?
I mean, it's only Tuesday, so it's been 2 days, and I took today off for election day because the polling place this year got moved to like the other side of town, which would have added an hour or more onto my commute, which has already had an extra half hour added onto it because there's massive construction on my normal way to work. So rather than spending 4.5 hours driving to and from work today, I was like, no, I'll just take the day off, go and vote. And I dinked around in the snake room, cleaned up some cages, and had the day off.
Nice, man. That's a win. Ben, did you also take the day off?
Oh no.
Good answer.
I tell people I quit my full-time job and now I have an all-time job.
Yes. Isn't that the best part about owning your own company? You think it'll be less work, and then it turns out you work 80 hours a week.
Yeah, I'm much more stringent and strict on myself than any other boss I've ever had. That's for sure.
There you go. I mean, that's good though, right? That's good. So how has the week been?
Good. Busy. Good. Yeah. Lots of good stuff coming through, so that's fun.
Oh, I mean, what kind of good stuff? You want to share?
Yeah, we just had a episode go live a half an hour ago, so some people may have seen some of this by now, but it's pretty brand new. So we do have a very good candidate for puzzle. So we're very excited about that, and lots of people have been waiting for that. So I still have to chase it down, but it's a very, very strong. The mapping looks really good. And are we frozen? Okay.
You are, but we can hear your voice, so you're good.
Okay, good.
Yeah, we're good, man.
Then we've also got a really strong hit for TSK Xanthic and for GCR Xanthic. So we're very excited about that. We go from a few months ago having no Xanthics to hopefully within a couple of weeks we have 3 different Xanthics we can.
Yeah, I'm kind of shocked by the GCR, to be honest. I did not see that coming.
And Jeff, the person, the Gateway City Reptiles, the person that found the GCR Xanthic, he told me that they've been saving sheds to be able to help develop the test. And now that we've got a good candidate, I'll have 83 sheds coming to me this week.
Wow. Okay.
That's good. Yeah. That's good.
So I will definitely be able to verify, validate all the fun that I want with that. I can do 80 from them and 80 that I know don't have it. And if that works, we're good. And if it doesn't, I've got 83 more I can sequence.
Dude, that's awesome. That's fantastic.
Yeah, that's sweet. Backing up a new project for sure. That's a lot of sheds. That's between him and one other breeder. They've been saving them up, and they talked to us at Tinley, and ended up we found it with the few that we had, and so now we've got a bunch to validate.
Nice. Had like 50 people ask Monarch ?
So Monarch we had on this run. And what it looks like is, unfortunately, so first of all, when we did the mapping, it was really weird because we had a whole bunch. So we had a bunch from 3 or 4 different people. So we had plenty of homozygous and heterozygous monarchs in the run. But it looks like the homozygous ones give us twice as much information about where that mutation is. So they're the most important when we're doing the mapping. And it looks like 8 or 9 of them were poor samples. And so that might be why the first time through trying to do the mapping, it didn't look good. So we're going to try to adjust things a little bit and see if we can pull something out, but we might have to sequence again. So if you have homozygous monarchs that you haven't sent in yet, keep sheds, and in a week or 2, if I say we need more monarch sheds, send them in. But I'm still hopeful we do another run, another pass through with the bioinformatics. Maybe we'll get lucky.
Nice. Travis, you gonna send in all your monarchs?
I don't have any monarchs. I do still have a box of sheds that I need to send Ben. But every time I'm like, okay, I'm ready to send it, I look in a cage and I'm like, oh hey, that guy's about to shed. And I'm saving up other things because I know Ben has, like, aside from all the ball python and morph stuff, Ben wants other species and things. So I've got Calabar boa, I have so many beak snakes, I have kukris, I've got just all these other sheds that I keep grabbing, and every time I'm like, okay, I'm good to go, it's like, no, wait, somebody else is shedding, I should wait for that one to shed for Ben. And
awesome.
I like how you end up porting them though, because you're like, well, I clearly can't send the 400 I currently have because one more is just a make or break. I just can't do it.
Got to make it happen, Travis.
Yeah, I know.
Or just send me your address. I'll come pick them up.
Wow. He never offered that for me. So
once it gets to 400,
I don't have 400, but I do have a bunch.
I picked some up from you in the middle when we met at the lab.
Yeah.
Touché.
I mean, I dropped off a whole bunch to you at a
with
Carpet
Travis,
Fest years ago. That was just that one weird Partho clutch thing that I had going on
at Carpet Fest.
Yeah.
And then Patrick, I met at his lab. He helped me with some of the early sample prep stuff when we first got going, and
just a little bit.
Yeah, like what, 200 or something.
Oh my God, that was that was fun. That was fun.
And then we had some hiccups and had to redo, and good times.
Buffer ATL isn't strong enough.
Sometimes you use up your swear words before 10 o'clock a.m.
Dude, there was that moment where we were like, this is gonna work, and then like 10 minutes in, we're both like, uh-oh, this seems like a problem.
No.
Yeah, basically. We got through it though. We survived. God,
yeah,
it was painful.
That's the good thing. We're both pig-headed enough to keep going until we make it work.
I mean, I think that's part of just getting a PhD in general, right? I've always said it's not actually about being that intelligent. Like there's a minimum you have to be to get in. But once you get in, a lot of times it wasn't the crazy smart people that did well. It was the people that are too stupid to realize they should stop.
So, I don't know, but if I would say stupid, I would definitely say stubborn. It's like, that didn't work. Okay, well, I'm going to make the damn thing work. And then you just hunker down and make the damn thing work.
Oh, yeah. Lots of those moments.
Yeah.
The other cool thing that this week I validated the Blue-Eyed Lucy tests that Dr. Hannah Sedell came up with along with her students at Eastern Michigan University. So
nice.
We'll have excuse me. We'll have tests for Phantom and what's the other one that's like Phantom? Mystic. So Phantom Mystic, those are identical mutations. And then Mojave.
Those are subtle.
Yeah. Mojave, Special, Bamboo, and then both in my testing, Lesser and Butter so far have been identical.
No. Shock and stun.
So we'll have some Blue-Eyed Lucy.
I really do appreciate on some level, like as we dive into these genes, right? Like the Butter Lesser debate, right? Where people have screamed for, I mean, since I've been doing ball pythons, and since Ralph brought them in. No, they're different. They're different. It's like, but are they?
Yeah.
I have been one of those people that has said forever, they're the same thing. They're the same thing. The only difference is in the unintentional selective breeding that has happened where people
Yeah.
are, you know,
and
picking
maybe
what
that,
looks more buttery and calling it a
yeah,
butter.
and maybe that's actually like ironic now that in the beginning they weren't different, and now maybe they are, right? Maybe now, because it's probably been 15, almost 20 years since those genes came out. We're probably 5, to maybe 10 generations in on some of these. And so it's like maybe we are starting to actually line breed a little bit to where there is some, other enhancer genes that are floating around in those collections that are maybe butter and lesser actually are a little bit different now. Who knows?
Yeah.
Well, the mutation itself isn't different, but I
Exactly.
could certainly see,
The
and
population.
I have said, when I have talked to people in the past, I have said collections are genetic
Yeah.
because like everybody has got their own look that they like. Some
Oh, yeah.
people like things that are
Yeah.
striped. And if you look at their collection, a lot of their animals are very stripy. So that there are genes that contribute to a striped phenotype there.
Yeah.
And
100%.
in their collection, there's going to be a lot of those genes. Other people like banded animals. So those collections have got a lot of genes towards banding. Some people like animals with really bright flaming and blushing.
Yeah.
Those collections are then going to be really rich in those kind of genes.
Yeah, I think that's actually, I think it harps to like, people sometimes would be like, oh, it's just pastel. And I'm like, there's probably 150 genes that are helping to regulate that look. Like there's one mutation that's central to like the pastel phenotype. But when we start talking about blushing and the striping and the banding and all that, there's a lot that's going on into that one look, right? And so I think that's also, a good point, Travis, in putting that really nicely. Like everybody's collection has their own little hint. If they've been doing this long enough, right, they either have their own little touch to it or they have the touch of the people that they've bought from, for sure.
Yeah.
So, yeah, I like that. That's interesting. So that's cool. So I don't know, Ben, if you've talked to Hannah much about why she picked some of these mutations. Like I assume she picked the Bell complex because leucism is a cool trait to kind of teach students about, ? Or
Could be. I mean, she did yellow belly already. Maybe she's kind of going for the different white complexes. I don't know for sure.
Huh. Yeah. It's
Then
just
she
interesting.
threw hypo in there, and so I don't know.
I wonder if hypo happened just out of like demand from other people, right? Enough people were clamoring, being like, "Oh, let's do this."
It seems to me when I talked to Hannah that her mode of deciding what project she's going to do is, hey, here is a morph or a group of allelic morphs that I think I have an idea what 2 or 3 most likely genes are that would cause
there
it.
we go. Yeah.
Goes in and sequences those genes and sees if she sees something weird. I think she kind of goes at it completely opposite way than we do, where we say, okay, we want to go after, monsoon. So let's get as many monsoon sheds as we can. And we just sequence everything and use the bioinformatics to figure out what's different.
Can we real fast, since we kind of stumbled on this, can we talk a minute about like, because what you just said, right? Identifying the target, this is like novel gene discovery. Can we talk about that process? Because I feel like I end up explaining it a lot to people. and I don't know. Yeah, somebody needs to do it, Ben, because you are. I'm just kidding. But yeah, can we talk, like, what does that really look like, right? So the process, right? So somebody says, we'll use monsoon. Somebody says, Ben, I've got 100 sheds for you, which is excess, but I got 100 sheds for you. How do we make the monsoon test?
Yeah, so thankfully we have a bank of now probably 500 or 600 ball python low pass whole genome sequences. So they're individual animals that we know don't have monsoon. So we have a nice big pool that's our negative pool. And so we would use that 100 sheds that we know have at least 1 or 2 copies of monsoon, and we pool those together. So we have 2 pools. One pool, we know every single animal has 1 or 2 copies of monsoon. The other pool, we know none of them have any monsoon whatsoever. And then we use bioinformatics to go in and say, okay, scan through the monsoons, find any change, and then look at the other pool and see if any of those animals have that. If some of them have it, then you go back and scan some more, find another change, go back to the other pool. Do any of these have it? Yes. Okay, throw that out. Go back, look through monsoon. Oh, here's one that's in monsoon. There's a change there. And when we go to the pool of negative, none of them have that, then that gets flagged and sent to me. And that's a positive, that's a possible candidate for me to go after.
So real fast, just can you explain when you say low pass sequences, what do you mean by that?
So when we talk about, you hear in the media, doing a whole genome project or, the human genome project, to know for sure, where all the genes are, to map everything. It's such a huge amount of information, and there's some repetitive things and things that get swapped around, all this stuff. So, to do a really deep, good whole genome sequence for a species, you're talking like 100x at least coverage. So if there's 3 billion base pairs in, the human genome, 3.2, whatever it is, you have to do 100 times that. So you're doing 320 billion base pairs that you're sequencing to get that 100x. And so for low pass, we don't need to map the whole thing because we've already done that with the ball python genome. We've ourselves, RGI, we have a whole genome for the ball python. So we can go through and have samples come through and just go like 1 to 3x. So we have a very low coverage of the entire genome. And if we have enough samples, we might miss. So like if we have 100 sheds that Monsoon is in, and we're doing low pass, maybe 10 or 20 of them, that we don't actually get sequencing where the Monsoon is, but that doesn't matter because we've got 100. So we're kind of covering it by having a whole bunch of samples rather than doing, the whole genome project for the human, we're doing a whole bunch on one sample, whereas with the Monsoon, we're doing a little bit on a whole bunch of samples.
I can throw out an analogy.
Yes.
It's kind of like if you have a book that you have read 10, 12 times that you absolutely love that book and it front to back. And then somebody hands you another copy of that book that's been republished and just says, hey, real quick, read this through and tell me if you catch anything wrong. You can kind of speed read over it. And, if it's a new publisher or a new printer or something, as you speed read through it, you might be able to catch, okay, like, you're reading. All of a sudden you find out that like the first page of chapter 12 is missing, just in a quick speed read. That quick speed read is your low pass. But the fact that you've read it 10 times over before and everything that's going to happen 10, 12, 15 pages before it even happens, that's your high pass that you've done in detail.
Yeah, I think it's a good analogy. And then you can take it a step further in the way that, we overcome deficiencies in low pass, right, is repeating it. So samples. So instead of just reading that book, speed reading it once, right, having, 10 people speed read it, and that's how you're overcoming those sample deficiencies, which is, the depth deficiency, I should say, not sample. So nice. So for y'all's method, Ben, I know in the lab, like we generally stick with like 24 to 48 samples. Is that kind of ideal for y'all as well, or?
It varies.
It varies.
Yeah, it depends on what all we're doing. And we also, to be able to get a price, we're always trying to keep things as low price as we can. The two things we're always trying to do is get a low price, but then also, have some speed, we hope, which, that's very hard to do unless you have really high volume. But yeah,
that flow cell.
So yeah, if we need to fill a flow cell and there's only, 1 or 2 genes we're interested in, we might have to have a lot of them. But if we have a whole bunch of different mutations we want to go after, and we can share the cell with someone else and still get through quick, then we don't have to have as many. So it really varies. It's not a set thing. If we had our own machine and hundreds or thousands of samples coming in every week, then, we would set up a protocol and follow it. But maybe someday.
Well, once Travis actually sends you all of your sheds, you'll be good.
Yeah.
I'd like to blame this entirely on Travis. How's that sound?
You can do that. That's fine.
Oh my God, that's amazing.
I think the only thing that I really have now that Ben would need would be I've got a bunch of acid stuff.
Okay. So somebody in my Discord brought up, and they're like, "Oh, I'll just test my animal for confusion," and I was like, "I don't think that's a thing," but do y'all have a confusion test now that I don't know about?
I have one that I was liking for a while, but then it wasn't working very well. It wasn't working all the time. So
That's not a solid test, yeah.
Yeah, I definitely know the general I definitely know chromosome, and I know general location. That's same as spot nose and pastel and fire. There's quite a few that I know pretty well where they're at, but I haven't found a test that works reliably yet.
So
you know what block they're on, you just don't know what house yet.
Yeah.
we have to kick the door down. So, okay, well, that takes, I guess, to the next step then, right? So we found these spikes, the differences between the wild type and the mutants, right? Whatever mutation it is. So now I think people assume like once you get to that point, you have a test. And in actuality, you don't really have a test, right? You have targets.
Yep.
Right. And so I guess can we talk about that part too, right? So you now have a list of targets, right? I don't know what y'all spit out normally. We're looking at like 10 to 20 ideal targets, but whatever y'all spit out. So like what's the next part look for y'all?
So then we have to design a PCR, we have to design primers and do the sequencing, and then we have to have a bank of samples. So since this is a new test and we don't know if it's the right location for sure, what we need to do is sequence several animals we know. Like if it's for monsoon, we would want to have like 10 monsoons and 10 het monsoons and 10 that we know don't have monsoon, and run those 30 for that new test. And if all 30 of those match what they should be, then I would run another 50. And if those all match, then I'll run another 50. And if that, all of that matches, that's when we would say, okay, we've got a test.
Nice. And so if it doesn't all match, what happens at that point? Do you just call it like, okay, this is a marker test or whatever, or do you just kind of scrap it for the moment and y'all look for another list of targets?
Oh, I scrap it forever and go to the next positive, next possible hit, the next peak, or however you want to think of it. So there's a group of candidates that I'll get, and I'll go for the one that looks the best, the cleanest, the strongest. And a lot of the time that pans out. Sometimes it doesn't. Sometimes the second one doesn't. Sometimes the third one doesn't. And sometimes I just have to say, okay, we got to resequence for this. It's not going to work. I hope that's not what's happening with Monarch, but this first pass with it, there's just nothing that's usable. So
nice. So do y'all, when you're doing it, you're just testing one target at a time. You're not batching it and just assuming that the first target's going to be a whiff and going for like 3 or 4 deep.
It depends. Sometimes I'm testing 10 different new things. So I'll just test one for all of them, and whichever one looks good, I'll chase that, and then I'll go back later and do another. But sometimes I'm only doing 2. So I'll design like 4 different PCRs for 4 different places, and sometimes I'll design 2 or 3 PCRs for one spot because it looks like it might be a little difficult. So I've been designing PCR tests for over 20 years. So I know a lot of little tricks.
Yeah.
I know when to expect a problem. I know how to get around it. I know how to, I know when I need to have 3 or 4 designs, and I know when it looks like it's going to be easy, and I'll just design one, and 99% chance I'll get it on my first try. So, that's hard for someone else to replicate. Not many people. My very first ones I designed were in 2002. So it's been a lot of PCR design that I've been doing for a long time.
That's painful. I was going to say you're a little more optimistic than me. I always just assume like the first 3 targets are just going to fail, and I just am like, well, we're going to brute force this shit. I gotta think that goes back to Travis just being stubborn and being like, no, we're going to make this work whether it wants to or not. So oh my God, I love it. It's fantastic.
I definitely have a big bag of tricks that makes a huge difference.
I mean, it helps, right? I mean, that comes from experience. I mean, Travis, I assume you're kind of in the same world. You got a nice big bag of tricks that help you with your stuff. So
I mean, I will say that it's a lot easier nowadays to come up with PCR tests because the bioinformatics tools have gotten so much better. Like Ben, I have been designing PCR primers for 20 plus years. I remember having to basically do it by hand, where you'd have to print up each alignment as a different line. You take like
that's
6
so
different
brutal.
alignments and
Yes.
type them up as as a Word document, and then merge them and try and find that
Yes.
one place where they all matched up. And
4 degrees for a G or a C, 2 degrees for an A or a T.
yeah, and
guys, that's
man,
painful.
that was so painful. So it's a lot nicer now to be able to just plug all that into a program and have the program tell you like, this is your best candidate, and then you grab that one and you send it off to IDT, and they send you primers 24 hours later, and you're in the lab mixing it all together, and bam, 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 bam. But yeah,
Kids-
sometimes those
kids
primers
these days.
sometimes even those primers are that the bioinformatics come up with aren't ideal, and you need to play a little bit, but they're a lot better than they used to be.
Yeah.
Now it's
for sure.
2 or 3 times testing it and
Yeah.
getting it refined versus basically the entirety of your first semester graduate school rotation.
Yeah.
All you did was design one primer set, and that was considered a great activity.
Well, it's funny you put it that way, because my PhD wasn't, it feels like quite a long ago as y'all's, but still, almost a decade ago now. And it's like, it was effort, right? Like you're saying, whereas like over the summer, I gave a list of primer targets to an undergrad, and I was like, hey, I need PCR done on all of these. Please go make primers and run gels. Thank you. And a week later, she had like 15 targets done, and I'm like, man, I couldn't even imagine doing that as a grad student when I was in grad school. Like,
That's awesome.
Yeah, within a couple of weeks, right? You're like, Jesus.
The other huge thing is the polymerases the kids have to play with now. That kicks the
So
crap
much
out of the
better.
ones that I had.
Oh my
In
God,
one
dude.
lab, we even made our own.
Yes.
In
platinum.
coli.
Yeah. Yes. There was nothing better than going to the lab next door, and they're like, yeah, we're doing another batch of platinum tack. You need some? I'm like, yeah. And they have this like 1 liter bottle, and they're like, there's like 200 grand worth of platinum in here. I'm like, fuck.
Yeah.
That's amazing.
Yeah.
And you're like, isn't this illegal? And they're like,
yeah.
Only if you get caught.
Maybe not illegal, but sketchy as hell.
Yeah, well, I remember always asking people that, right? Like, why don't we just sell it ourselves? Like, guys,
that's where it gets to be kind of illegal.
Exactly. But I'm like, guys, this feels like this is how we make the money right here. Like, come on.
Made my own competent cells in one lab also. That was fun.
Yeah. My first postdoc, we didn't buy competent cells, we made them. And
yeah.
I went from a lab that had all the funding, like 4 or 5 R01s, a V8 grant, like the works, right? To then my first postdoc lab where she's like, no, we make everything. I'm like, okay, this is a whole new world. So
yeah.
Oh, I love that.
Money's tight if you're making your own competent cells in the 20 teens.
Oh, for sure, man, for sure. All right, so let's see, where we made a test, so now we have a valid target. So now what do we do once we have our valid target and Ben is content with his validation process?
Yeah, so once I've got over 100 and everything looks like it lines up well, that's when we make it available for customers.
Nice. And so then it's just sequencing and life goes on, and we I assume batch on some level. I don't know if you're allowed to say, is this being done with next generation sequencing, or are you doing something other than that?
Yeah, I don't do any Sanger. I don't do any old school stuff. We're all next gen.
Ben's like, I'm too good for that shit. Okay.
The kind of numbers we're doing, it would be more expensive to do it by Sanger, and it would be more of a pain in the ass. So, I mean, there's no reason to do Sanger when we're doing the kind of numbers we're doing. If we didn't have as much throughput, then yeah, I can see where you'd want to do Sanger, but yeah,
for what y'all are doing, it's next generation. So with that though, the drawback, just for people who don't know, I would argue the drawback is you have to batch stuff. Like, it's not on demand as much. You have to batch. And so, I don't know what y'all's volume is week to week, but you gotta optimize those flow cells as efficiently as possible.
Yeah.
Right?
Yeah. And that's why, like, when we tell people turnaround times, we say right now it's around 3 weeks. If you get it to us right when we're about to do a run, it'll be less than that. If you get to us right after we do a run, it's going to be longer than that. But yeah, we definitely have to batch. And we're hopeful the numbers are trending, because now we're over a year where we're able to collect numbers. Last October, when we really started doing this at a kind of a real level, not just me trying to email people results all the time. They're actually legit. And so yeah, the numbers are trending where I'm hopeful that through 2024 we'll get to where we're 1 to 2 weeks instead of 3 to 4, sometimes 5. So.
Do y'all have enough samples coming into where you're running every week, like a plate, or you're filling a flow cell, or is this still every couple of weeks y'all are doing runs?
Some weeks we can run 7 days. I would say over the last few months, most of the time it's like 10 days in between. Sometimes it'll be a full 2 weeks in between, but through these slower months, through the winter with less samples coming in, it might be more like a full 2 to 2.5 weeks in between.
I got you.
Yeah.
Oh man, you know what it was? It's RGI shutting him down. They're like, he's giving away all the secrets. Oh, are you back, Ben?
Yes.
You froze hard. I was like, RGI just shut him down. He's giving away too many secrets.
Sean pushed the button.
He did. Sean's like, nope, no more. The Mandalorian is coming in.
So yeah, that's part of why we're hoping to do a lot of research stuff through the winter, so that we can not fall into that where we're doing 2 or 3 weeks in between runs. We'll hopefully keep it to 10 days to 2 weeks, and maybe get it down. If we're doing a run every week, then turnaround time should be about 2 weeks, 2.5 weeks at the most. So I'd like to get to that, and hopefully during the busy season next year, we've got another person or two helping us out, and we'll be able to get those run times down. And there's some other things that we're playing with, different ways to run the tests. So if those things work out, then it would make it so we could have turnaround times much faster.
Sweet.
But we're playing right now. There's nothing going hard, but there's always new stuff in molecular biology. It's not quite like computers, but molecular biology moves pretty fast. So we're keeping up with that and have a couple of irons in the fire. So
nice. That's exciting. Travis,
and then the other
part
to that is the discounts we started doing for people. That's another thing. Hopefully we'll have more sheds coming in because of discounts during the cold season to keep those runs going, every 10 days or so. Yeah,
I was gonna say a 3 week, having to wait 3 weeks is painful, not, just from a customer standpoint, right? Of like, if we're having to wait 3 weeks for, the samples to be run, and then, another week or two potentially for data processing, it starts dragging out a little bit. So yeah, hopefully the discounts will help drive the customer base to y'all for sure. So Travis, when are you gonna go work with Ben? When are you gonna go do that? Quit the job and go hang out with Ben.
There have been days where I've seriously considered it. What we really need is somebody in the comments mentioned crowdsourcing to get Ben his own machine. If we could just get the machines and put them in my basement, so I don't even have to leave the house, I will do this shit. I will run tests all day long, and I'll be fine with it. Ben will have to deal with the fact that I'll be putting other shit on there, like my Ramphiopus and my Candoya, but Ben wants that stuff in too, so he won't object to it. So if you guys, if we could get the whole community to come together and buy the machines, and I can walk away from my desk at work and be able to do this from home and make a good living, I will absolutely do it.
I mean, guys, we just need like 500K for next seek. It's not that bad, right? We get a nice mid.
I think next seeks are even less than that. I think they're only.
I think you can get one for like 250.
But that's the low end one, right? There's like the next step up, like the next seek.
No, that's like the mid step. That's the next seek 200, or the next seek 200.
Yeah, but there's the next one up from that's like the 500, right? Am I misremembering? It doesn't fucking matter. They're expensive.
I don't remember them being that expensive, but the one I want's the Nova anyway. So
the one I want's the Nova. So I can literally run 5,000 ball python samples with full panels all at once. Okay.
Well, I want to get to where we're doing a lot of the tests as being low pass whole genome and having the software make the morph calls. We're also building that right now. I was hoping we would have it faster. We was hoping, maybe that was definitely, I know now, way too optimistic. I was hoping we'd have it by this fall, but yeah, I would love to be able to have the kind of throughput, because in that case, it doesn't matter what species. We can be doing chameleons and monitors and geckos and ball pythons. But if there were low pass whole genome tests that people are interested in, either for purity or for morphs or for all kinds of localities, there's all kinds of different questions, and we had enough coming through, then we can just run everything as low pass whole genome instead of having to do 30 PCRs or something like that.
I mean, that is nice. That adds a little bit cost per run though, right? Or per sample, right? Because you're
definitely,
so it gets a little more pricey, but it's still cool. I mean, that would be great. Sorry, what were you gonna say?
I was gonna say that one of the nicest things about that for ball python breeders is you would pay that, maybe it's $130 or $140. You pay that one time, and then what we plan to do is you can update your information anytime for $20 or whatever. So you can wait a month or two, and we have a new test come out, pay $20, and it'll test it for that new test. Or you could wait 2 years when we have 20 new tests, and you pay the $20 and you get the results for all 20 new tests. So that's cool, because you don't have to send another shed in. The information's there, and then we just have to wait till we've got the location identified and the haplotype that we can look at, use the software to make the morph call on.
Yeah, no, I think that actually will be really awesome. I think that's I don't know if people appreciate yet how useful that will be.
Oh, yeah.
And
it'll be awesome.
It is nice.
And we'll be able to have partners in other countries that can, get it sequenced. They don't even have to. It would be a much cheaper price if they can get their own sequencing done in the country they're in, and they just send us the data. Yeah, and all we do is just throw it through our pipeline and make all the calls and give them their information. So that makes it so we can be international at that point, because we don't have to send sheds anywhere.
Yeah, that'll be cool. That's awesome. All right, so the comments are just being obscene right now and outrageous. They want to know about Desert Ghost stuff, so I guess we should take a moment and talk about the problem child that is Desert Ghost at this point in the ball python community.
To me, it's cool and exciting. I don't see it as a problem child. We've said from the beginning, we had 2 locations that gave us good information, that did a good job of making a call, and we always said there's at least one other one, and now it looks like we're finding that third one, and it might be. I assumed that A or B would be the best. Gene would give us the best information on whether it's a visual or for sure a head or whatever. But maybe this third one is going to be better. So the other groups are reporting they think that it is. So far, the testing I've done with ours, we're calling it our DGC test. It does look better so far, but as I run more, I might see what the other groups are saying, or as they run more, they might see what I'm seeing. We'll see.
So I don't know how much you can say, but I'm going to ask just some questions. If you're not comfortable, please just tell me to shut up. But no what's that?
No problem.
Oh, okay. I think you said shut up. I was like, perfect. Let's go.
No. You know me well enough by now. Yeah. I'm not very good at keeping secrets. I'm a pretty open book.
This is more just kind of a numbers thing, right? So DGA, and so the announcement comes out, right? DGA, DGB. Desert Ghost is polymorphic, right? Cool. All right. There was, a level of uproar, which I have seen very few times in the ball python community. It was delightful. Feasting on that drama. We come out with the theory, right? It needs to be homozygous for one and het for the other to be a visual, and then we can deal with the aftermath of what hets actually are, right? Whether a het A is really truly 100% het or not. But more or less, like we had the idea.
And we definitely saw some that were het for DGA, het for DGB, but also visual. So that's why we were saying there's got to be a third.
So I guess that's where I was going to go with, because early on I know some of the people really pushed hard that we didn't discuss the what we'll call anomalies at this point, right? Because we had an animal sequence homozygous A only that was a visual, right? And I know Justin had some animals that were homozygous A, het B that weren't visual. So there were some anomalies, right?
Yep.
So at what rate did, like, in your known samples when you're doing validation, did like het A or DG, homozygous DGA, het B, whatever, come up at, like, to where you were like, yeah, this definitely feels like the target? Was it in your sample size like 100%, and that's why we ran with it, or was there some variance there?
I have a good report in one of our, I think it's episode 13
Okay.
of our Reptile Genetics Weekly. So in samples where, and I don't remember the numbers, if you go to that episode, I have the p-values and stuff, but what I do remember is in samples where people reported that there should be no DG at all, about 15% of the time we would get het DGA or het DGB, and not usually both. But like the p-values for, if you look at the pool of reported not desert ghost versus reported yes desert ghost, visual desert ghost, the p-values are astronomical. That if you have homozygous DGA or homozygous DGB, either way, your chances of that being a visual desert ghost is, a very, 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 very strong. It was like 10 to the minus 36 or something. I can't remember.
Okay.
Now. So, it was very clear that those two markers, those two locate, and these are on different chromosomes. So those two different markers on two different chromosomes were definitely highly correlated with a visual desert ghost.
So then my question would be, like, did we see the same high level correlation in like het A animal, like heterozygous? Because I think the visuals are one thing, the hets are where I think the conundrum comes up for just on the customer side, right? Because now, like, we don't necessarily question the correlation with the desert ghost and homozygous A, homozygous B, whatever. But like, if an animal tests as, let's say, just het A, right, het DGA, what's the likelihood that animal is actually 100% het? Like, is it 85%? Because somebody said that to me last week, and I don't ever remember you specifically saying that, but they kept telling me that, and I was like,
I did say that.
Okay.
Yeah, I did say that. That's what we initially talked about, the desert ghost test being an elimination test. So that's why we've never sold it like all the other tests. It's always been, desert ghost is a different thing. You're getting results for two different things. This is not like all the others. And we did on both Morph Market and Clutch called it an elimination test. It definitely was not at the same level as our other tests. And we've said all along, there's definitely at least one other spot that we need to find. And we've said that from the very beginning. We've said it pretty much every time we talk about desert ghost data. And now it looks like we're finding it. But yeah, the DGA, I would say is clearly better at predicting a real het than DGB. And then this DGC that we're testing now, on the three samples that I have, it definitely did a better job. I have 3 different desert ghost project males. 2 of them are visuals. One is I bought as a het. And with DGA, DGB, one of the visuals comes up as homozygous for both, and one of the visuals comes up as het for both, and then the het comes up as het for both. And when I look at DGC, I have 2 different animals that are visuals. They both come up as homozygous for DGC, and then my het male comes up as het for DGC. So C is calling my 3 males that I know for sure are what they are better. I gave a bunch of results to Justin where we've run DGA, DGB, and DGC, and he looked at it and he agreed. Yeah, the C definitely is calling things by itself at a higher rate than
Much
A
higher
could
rate.
by itself or B could by itself. But when we look at about 100 results where I have DGA, B, and C, and I know the majority of them, I know like 70% of them, I know whether they're homozygous or visual. I guess I should say they're either visual or they came from a visual, so they should be hets. and then about 25-30% were pos hets. We're looking at DGA and B together, calling it correct. When you're comparing it to C, I guess I should say not correct, but I should say DGA and B calling it the same as DGC does 95% of the time. So the vast majority of the time, they're agreeing. That other 5% right now, I don't know if DGC is right or if DGA and B are right. And that's what we'll have to figure out. Over the next couple of weeks, we'll run 200 to 300 more where we do know if they're visual or should be from a visual, so they should be a het. And that's when we'll have a much better idea. And we'll also be putting that up on our website. We'll have 100 of the free DG tests. So we have like 550. And that's the other thing we did because we wanted to find this out and we wanted to find the third location, at least third. We have 550 that we're running for free, and we're running DGA, B, and C. And as soon as I have that data, that will go on our website. Anyone can click on there. It has known genes, not for all, but most of them. People put the known genes. It has a picture that you can click on. You can blow it up. You can look at it yourself. And then starting next week, we'll have about 190 to 100 of them where we'll have DGA, B, and C results right there for you. Anyone can look at it and see for themselves. And we'll see if C is clearly the better test, we'll move from there. If it's still kind of awkward, figuring out what's really the best, or maybe we need to test A, B, and C, or, maybe just A and C, or, I don't know for sure what's going to come out. But we definitely, on this last batch of whole genome sequencing where we got the puzzle and the 2A xanthic hits, we also got a bunch more desert ghost data, and it looks the same. We get 2 really big peaks on 2 different chromosomes. So there's something. It's possible that second peak is kind of like what we were talking about earlier with Lesser and Butter, where selective breeding could have occurred, where people that were breeding desert ghosts were also selecting for a second gene that's on a different chromosome, but they did that so much that it's carrying, even though it's on a different chromosome, it doesn't necessarily make it a desert ghost, but it does make it what we think of as being a nice desert ghost. And maybe enhancers, they didn't have that going on, and so they don't have that second peak that they're seeing.
Gotcha.
We definitely see it. Like, it is clear as day. There's 2 different chromosomes that have giant ass peaks. There's zero question. The only question now is, are both of those peaks needed to make it a visual desert ghost, or is only one needed and the other one just makes it a nicer looking desert ghost? And so we've, without any focus or knowledge, we've been selecting for actually 2 different mutations, at least in this pool that we're testing in the United States mostly.
Yeah. All right. So a couple of follow-up questions real fast. So when you talk about DGC calling at about a 95% rate or whatever, matching up with A and B, is that A independent, B independent, and then A and B together? Or is that let's just say an animal is just het DGA, right? And then it tests for het DGC. Are you saying 95% of the time if DGA is present, DGC agrees with it? Is that kind of what you're saying at this point?
My analysis I did was looking at, so what we've been giving customers is A and B. And so what I was looking is, what we've been giving our customers, how different would it be if we gave them DGC results? And out of 100, there's only 5 that probably would have gotten different results. And those 5 were all pos hets. So DGA, B, and then DGC said different things, but they were all 5 of them were pos hets. So I don't know which group is right. If they were all known hets, then I could know, okay, DGA and B is the right one, or I would know DGC is the right one. But since we're going to run 200 or 300 more over the next, 2 or 3 weeks, we'll have those pop up where it will be in known hets, and then we'll know if one is better than the other, or it's not consistent sometime, and we need to run all 3.
Yeah, I'm excited for the spreadsheet to come out because nerds like Travis and I can then attack it. And I don't know if Travis is going to be as aggressive with it as I am, but I've been on the warpath since we got that first wonky result that A and B are just biomarkers. I know we've had this conversation more times than you'd like to admit. You're probably exhausted.
I'll admit anything.
Yeah,
Anything
I'm
that's
just
true.
like I know people are probably tired of me saying I don't think it's A and B. I thought the third gene was the one that mattered, and I've always thought A and B were biomarkers. And so I'm really excited about the data because I'm going to get to go through and actually do the math, and I'll be able to tell you real quick if it actually is a biomarker, right? Which I think what people are worried about is that they're like, well, if DGC is what matters, then it really is a quote unquote simple recessive. Well, all of this A and B testing doesn't matter, and that's not true. I distinctly feel it's not true because
Definitely not true.
right.
Yeah,
Well,
that's
one hell of a lot.
I was waiting to jump in because I wanted to
Yeah.
say the same thing. There's
this is
there seems to be a lot of contention as to whether what the Canadians said now renders everything that came before completely and totally useless.
Right.
And one of the comments actually says something along those same lines.
Yeah.
Now, with the further revelations that Ben is finding, it very well could be that C is the primary and it is simple recessive.
Right.
But A and B, like Ben touched on, those collections are genetic. There has been such a strong selection for these really, really high contrast, high quality desert ghosts that those two mutations that enhance that phenotype extremely are now so enriched in the desert ghost pool that initially they masked
the actual
fact that C was that primary mutation because the hit on them was so strong. Those, and those could just be some type of I hate saying enhancer gene because people think like, well, it's a yellow belly or it's, fire or it's something because those are enhancers. Those are color enhancers, yes. But I mean a gene that just by itself enhances something. Those A and B could be just like generally enriched through the hobby because they're a higher contrast
they're better
genes,
looking animals.
So people pick them inadvertently when they're picking a higher contrast animal out of their breedings. We've got high contrast albinos. We have high contrast in the black pastels. We have high intensity in orange dream, which really is just a high contrast orange dream. So if you're picking for these high contrast, high intensity things, and that becomes so enriched in a population, then when you're running it against that mutation and you start seeing those pops there, that just overwhelms the system. And so that's where everything went initially. And it's this further digging, this further data seeking, which, this is what science is. You go in, find the data, you say, this is what the data is telling me, but you don't just stop there. And Ben didn't just stop there, and the Canadians didn't just stop there. The Canadians came at it at a different angle, and the Canadians are also, and please correct me if I'm wrong, Ben, but my understanding is they're looking at enhancer.
No,
which is kind of an independent line of DG that it hasn't been going through the same type of selection that we've seen down here.
Right.
So it's basically a separate entity of the same gene. So all the baggage that the US population has, the Canadian population doesn't have. So they don't have that interference, as it were, of the A and B genes being thrown in.
The Canadians, their population is a higher percent enhancer, where mine is a higher percent DG. But I definitely have run some enhancers, and they have run some DGs. We've definitely run a heck of a lot more than they have.
Oh, for sure. So one of the things real fast, because there's one of the analogies I've been giving people, right, with the whole A and B and quote unquote biomarker idea is ringers and pieds, right? Just because an animal has a ringer doesn't mean it's het pied. There's a strong ass chance it's het pied, but it doesn't mean that it is. And so we selectively bred, and we do selectively breed animals that have ringers in our pied population for that. And I think that's a similar thing that's probably happening with A and B in my mind is, as Travis just said, right? These are high contrast animals, whether they're visual desert ghost or hets, and we're just picking out these nice ones and we're breeding those, right? Or it's pos hets, and people are like, oh, this one's probably going to prove, and it's because it has that nice gene, right? And whether or not it ends up proving or not, it probably ends up getting bred to a desert ghost, and so that A or B is getting mixed into the population intentionally or not, right? And so I think that's an important like thing to kind of, in my mind, I think it simplifies a little bit in saying like I look at A and B almost now, assuming C is actually the causative agent, right? This is still the question, but assuming C is the causative agent, I look at A and B almost as like ringer gene, pods. And it's like, yeah, it's an indicator. It doesn't mean 100% of the time, but a lot of the time, it probably is going to prove out.
Yeah.
Somebody in the
I'd
comments,
say I definitely know for sure right now A and B cannot predict it, at 100 or 99.9%. I mean,
yeah,
the A and B definitely cannot. C might be able to.
right.
I can't rule that out yet. So yeah, what you're saying makes sense. That could be what we find out is that they are associated most of the time, but not all the time, whereas C is associated all the time. That's possible, but I haven't.
Patrick's ringer thing. It's, if you look at it as, if you think of it as sort of like a Venn diagram, if you have a pied breeding, if I breed a pied and the litter has animals that have ringers, I can pick a ringer animal from that and know that it's pied very strongly because obviously I know that it's pied, but that ringer is there. But if I just find a ringer out in the wild or at a show, there's no absolute guarantee, but there's a very strong correlation because we have selected for ringers so much in pied.
Right.
If I know that pied was in the breeding and there's a ringer, I have a much higher degree of confidence that by picking that ringer, if I breed a het pied to a something that doesn't carry the pied gene, or if I breed two het pieds together and I get a ringer and I also have a non-ringer, if I wanted to say what is the highest likelihood that I'm going to get a het pied animal, I'm going to pick the ringer animal.
Right.
Because it's not a guarantee, but it is
right.
such a high correlation that ringer means that it's het pied simply because we have selected for ringer with het pied that we're safe. Know that.
But even if that animal with ringer doesn't end up being het pied, most likely we're going to breed a pied into it, which further reinforces the correlation because
Correct.
we're getting ringer into the pied mutation even deeper. So it's this vicious cycle that feeds itself when it comes to these markers, whether we do it intentionally or not. Real fast, somebody in the comments asked a couple of things. So the first one was, does this mean A and B testing doesn't matter for pairings? And then the other person says, does this mean all the tests are wrong? No to both. So in my mind, and y'all please correct me, we have been going under the assumption that these are biomarkers. They're not 100% correlated. So when I saw an animal that was only A or an animal that was only B, I personally looked at that as less likely for it to prove out het. When I saw animals that were het A and het B, I felt like there was a much better chance that those animals were going to prove out het. So I think the percentages are right now based on what we know, and the fact, Ben, you said like 100% of the time it doesn't call it as a true het, but it significantly increases the odds that your animal actually is het. So if you test an animal and it tests het A, it's going to be higher than 50 or 66%. I don't know that math yet. Once we get the spreadsheet, I will be doing a whole episode where I go through the math, and hopefully there's enough numbers that I can give you a very definitive correlation rate.
We'll have about 100 for you in a week, and by 3 weeks we should have 200 or 300 for you.
Perfect.
Just in the free DG stuff.
Perfect. Yeah. So we're gonna be able to get some good correlation data, and I'll be able to, and RJ may already have done this math, but I'll be able to tell you very definitively, if your animal is het A, it has an 87% chance of being het desert ghost. If it's AB, it has a 98% or whatever that is. So it's not that the data is useless. You just need to adjust it slightly. You can't, just because an animal is het A doesn't mean as of now that it is 100% het desert ghost. It means there's a high likelihood that it's het desert ghost. Is that fair to say, Ben?
From what we can tell right now, yes.
Right. From the known data.
For me, I would look at the DGA and the DGB data together. I wouldn't just look at A or just look at B. But yeah, yeah, the point you're making definitely from what I know right now is correct. Yes.
Yeah. I think it's important to really emphasize what you just said, though. You're looking at A and B data together. Um, and maybe that's something that maybe this is a modification RGI might want to consider doing. Because if an animal comes back as het DGA, it is listed as het desert ghost in like Morph Markets reporting. And so that may be kind of a misunderstanding for certain customers, right? Where they see like, oh, well, if it comes back as het DGA and it's being reported as het desert ghost, well, it's not truly het desert ghost. It's a high probability it's het desert ghost. Does that make sense? Just a thought. I mean, I'm not trying to be a dick here. That's just as you. I was always under the assumption that if it's just het A or B, that's what we're rolling with. But if you're talking about your numbers are coming from animals that are like het A and B, that does kind of change up the math a little bit. And maybe if an animal is only like het A or het B, it'd be interesting to see what the actual numbers come out to. Like, what are the odds that this animal, and also animals that are like homozygous A, like, does that actually increase the likelihood that it is heterozygous or, actually het for desert ghost?
I would imagine so.
It's a safe bet, right? It's a very safe bet. But yeah, no, I think
like one I ran for Andre early on. It was before we had the DG test available. I got homozygous for. I was only running DGA at that point.
Yeah,
I ran it.
For A. Yeah. Oh, Sean pushed the button again. Sean's like, Patrick asked Ben the wrong question.
There we
go.
Like, no, it is definitely not a visual DG. And so I said, well, then it's really dang good chance it's a het.
So awkwardly enough, I don't think it's a het either.
Really?
Yeah. So we're almost 50 eggs in and no visuals, and that's to visual animals. So I'm curious. Yeah, I'm curious to see. It could just be very bad odds. I want that to be clear, but like we've bred it pretty heavily, and no visuals yet. So that's once again that was another kind of anomaly that we kind of
very strange.
Yeah, and once again, it could just be bad odds, right? Like shit happens for sure. But he has not proven het yet, which is frustrating.
That is definitely crazy.
It's weird though, right? But I think that once again goes back to the whole like stuff like that really kept reinforcing my whole like biomarker thing. And I know, people are like, no, and I'm like, guys, it just feels this way. This is how it feels. My soul, my ancestors are telling me.
Like what we said from the beginning, we know this is not telling the whole story. We know there's at least one other part to the story.
Yeah.
I said many times there could be 5 or 7. There's definitely at least one more. So yeah, I would have agreed with you from the beginning. And I think the other really good thing for people to keep in mind is we've been blessed this last year or 2, 3, whatever you want to reach back to, and things really started popping. But I mean, 2 years ago, the only test we had was a sex determination test for colubrids. 1 year ago, we had like 6 that we could test for. And, until a few months ago, you're dealing with 50% chance and 66% chance. Now, when we first let the desert ghost thing go, we said, it's probably like 85% is what we're seeing. And now, it looks like maybe DGC will be even better.
Yeah.
This is progress. This is science. This is progress. And we've been as open and honest as we could be. We've tried to make as many, we have lots of desert ghost videos that we've done. And I've talked to lots of people. We've tried to be as upfront and give as much information as we can. And as more comes out, we will definitely, obviously with the online thing, everyone's going to see.
Yeah.
And
it's good.
As that moves forward and we have more confidence, and maybe some of the other groups will do a publication and we'll know even better,
Yeah.
I'm excited to see what the real story is and to make tests better for customers. That's all I'm about. Every time we know more, I'm happy. None of this makes me frustrated. This is a good thing.
All right. I know, right? Y'all talk for a minute. I need to go get a charger for my laptop because it just let me know that I'm not actually plugged in. So I'll be right back. Y'all talk.
All right. All right.
What do we want to know?
So how many acid sheds do you have?
More
than a dozen?
Oh yeah, more than a dozen.
Yeah. That's worth driving. I'll come drive and get them from you. What we should do.
I can try and find a way to, get somewhere proximal to you, but I generally don't end up going south for anything.
Yeah. And I don't go that far north very often, but maybe we meet in the middle and have dinner one night or something.
Yeah, we could try and swing that. Oh God, ouch. All right, let me see what people are saying in the comments. Maybe we can address something else in there.
Yeah, there you go. I'm on my phone, so I don't see the comments at all. I guess that's a big downside to being on my phone.
Okay. Well, here's one. Troy is asking if there is a way to be testing from scales or from the egg.
So it's not something that I want to make broadly, broad knowledge to all keepers. But breeders that have been doing this for a while, I definitely don't mind sharing that. My favorite way to get a sample, whenever I'm getting them from my animals, like if I'm going to validate, like when I was validating the blue-eyed Lucies, I went out to my room and I did scale clippings from like 30 animals that I had that were blue-eyed Lucy-ish animals, either one gene or two genes of the various blue-eyed Lucies. So the best way to do that is you get, kind of smaller fine tip scissors like a lot of people use for slitting eggs. Flip them over, especially if they're a juvie or an adult. You probably wouldn't. I wouldn't want to do this on a baby. Maybe you have steady hands and you'd want to, but if it's either a juvie or an adult, I got a black poster board and I set that on my cart in my snake room. I flip them over, belly up, and I just shave off the edge of one of their belly scales, so it literally looks like an eyelash. So it's just a shaving. I would do 2 shavings. And I would put that in a Ziploc bag and get all the air out, and then just circle with a Sharpie so that I know where the crap in the bag the shavings are. And most of the time they stay put if you do a good job of flattening so that there's no air in there. But that I love that method. If it's a baby, I wouldn't want to do that, but babies shed a lot more often, so you don't really need to. It's not as big of a deal because you're not going to wait very long for a baby to shed. But for juvies and adults, sometimes you're waiting 2 or 3 months for a shed. That's a really good way to do it. If you want to split up your eggs before they hatch, then yeah, we could certainly take anything on the inside of the egg. Will be DNA from the babies. They definitely do that in birds. So they do bird sexing from the membrane inside the egg. But I find most people, like I know me, I wouldn't want to separate them before they come out.
Yeah.
Maybe some people do. If you want to, you could send us all we would really need is just like a little triangle of eggshell, including the membrane. Just set that out, let it dry, and send it. And we'll do the first 5 for free because we haven't done it yet. But I'm pretty confident that would work, no problem.
Sorry, this is a left turn as I'm reading through comments here. I'm trying to hit some questions. Okay, so as y'all are figuring, when are y'all going to start doing DGC in your Desert Ghost tests for like customers at this point? Is that something that's new?
Yeah. This week, any of them that go out next week, you will have A, B, and C.
Okay, so that answers. Somebody was like, when should we hold off sending tests in until you're doing C testing? I would say no, send stuff in now. If y'all are going to be doing all 3 from this point on, I think that is,
at least until we have 300 up on the free DG. Once we have 300 up there and lots of people can evaluate and look at, once we have 300 up there, then maybe we would adjust and maybe we'll only test for A and C, or maybe we'll only test for C. Maybe we'll say, okay, now we can throw out A and B. Or we might say, yeah, we need to do all 3 and we'll just keep doing all 3. But yeah, for now, starting the results that will go out on Monday and Tuesday, those will be, if it's for DG or for the panel, you'll get A, B, and C from now on, at least until there's 300 of the free ones up.
Nice. And I do really want to clarify for people, just so there's not confusion. An animal that tests positive for head A or B at this point, from what we know, like does not guarantee 100% het. So like, I think the people are still like, I don't know how that point has been missed, but it feels like it's been missed. And we're
That's
still,
what we've said all along. There's a third location that we knew was part of the equation.
yeah, I think
but
there's
A&B
been,
did a good job. We got us,
yeah,
85, 90%. It was very good. And like I said, we've been very, very transparent and upfront with that.
yeah, no, I get it. I think there was some, like when it first came out, I do feel like the marketing, intentionally so, like was good, but it definitely felt like, we dove right in with it's polygenetic, and so there was, I think Clutch had their little pictograph and things like that was kind of like, instead of just saying like, and I don't remember specifically, so if I'm wrong, somebody please make me eat crow, but I don't remember in that pictogram it saying like Hosmet or 85% or whatever. It just said like, these are the combinations to get stuff, right? And I think a lot of people took that and ran with it, and here we are. And so now they're seeing these new results that are coming out, and they're like, well, RGI was wrong. And it's like, well, it's not that they were wrong. They said there was another gene. I think some of the marketing early on, and people just kind of run with it, right? And unfortunately, as we know, like not everybody sees everything. And so,
For sure.
some people, I actually don't remember seeing the 85% number before. And so when somebody told me that, I was like, I don't know. I just figured it was correlated. I didn't know the number.
I
So
think it's even still listed in either Morph Market or Clutch. I can't remember which. I think it
Ben,
does say something.
People don't read.
I think they both say still that it's an elimination test. It identifies it, and I think in Clutch it has an asterisk by it. I mean, it's been very clear from the beginning.
Yeah, no. And I'm not trying, like, please don't feel like I'm trying to come at you. Like, it's just,
no, I don't.
Yeah. Yeah. I think there was confusion on it. And I think that people have misunderstood, right? And they've kind of rolled with it, and we all have. And so now, we'll see. What about all the people that have sold animals based on the GGT test? I mean, we've all sold animals on it. We went with what the current understanding was. I mean, I'm not sure what KG's want us to do on that one. But yeah, I think
the chances are that you're just fine. The test will get it right the majority of the time. Heck of a lot better than 50% or 66%.
Right. The odds are good. This, acts kind of like a biomarker, but like, for us personally, we've listed stuff, and we list the pairings, and we make everything clear that it was genetically tested, right? And we try to be as transparent with our customers. And, we've had customers ask what that means, and then you have to explain to them. And so KG, kind of my response to that would be like, I hope that the people that sold animals as tested hets were transparent with their customers and said that they were tested. I think that's a very important aspect to all of this, is people selling 100% hets that are tested as 100% hets without saying they were tested, right? Because whether or not we want to, acknowledge it, like air happens just in general, right? And so there is still even a bit of difference in a genetically proven het versus an actual het. And we've had animals that tested strangest thing in the world. I actually think I'd messaged Travis about it a while back, trying to figure out how it could be. We had an animal that came from a visual lavender albino female. It was a mahogany pied male that was not het for lavender. No idea how that happens. Like, still don't know.
Yeah.
Travis is trying to think. I see his mirror brain working.
It's androgenesis.
I remember it, but I can't remember what.
Yeah, so the pairing was a mahogany double het male, pied lavender, paired to a lavender het pied female. So mahogany pied comes out. Obviously, it's 100% het. Breeded a bunch of stuff. Never proves out for, the first breeder. I get it, and I'm like, well, you just had bad odds. So I breed it to a bunch of stuff. Visuals, not just hets. Never proves out. And I'm like, the fuck? Fortunately, about 6 months later, Hannah comes out with her publication. I'm like, well, good news. I work in a lab. I can do this. Test it, and it's not het lavender.
Did you produce that animal?
I did not produce it, but what's that?
The two most likely explanations for that is it really is the animal you think it is, and that was androgenesis instead of parthenogenesis. It's androgenesis.
So if it was androgenesis,
it couldn't be andro, because then it would be
have to be a summa. it would have to be a sumapide if it's andro, right?
Yeah,
No.
because it would get 2 copies.
Yeah,
Because
it would get
androgenesis
You
causes
said the male was a double het, right?
no, it was a mahogany
double het.
Yeah, the dad was a mahogany double het.
Right.
And
so
the mom,
it's heterozygous for 3 different things, so it could be a complete normal.
But the animal was a mahogany
double
pie.
het. So if it's androgenesis, it would get the double dose, the visual double dose of mahogany. So it appears a visual suma.
The visual pied offspring was a single gene mahogany, is what Patrick is saying. So it was a single gene mahogany.
That's what you're saying.
Pied that was not het lavender.
Gotcha.
Yeah. It was the offspring was a mahogany pied, not a suma.
Gotcha.
Not
I thought you were saying the breeder was the mahogany. Yeah. If the offspring just has 1 copy.
Yeah. Okay, I'm sorry.
So then the second most likely explanation, which we've definitely seen this happen, is that one of either the breeder themselves or one of their employees just swapped animals one day on accident.
So I would agree with you on that, except for I have pictures of the animal in the egg. So they would have had to have literally swapped a whole clutch and its siblings proved out. So like it really is like the freak genetic anomaly. But yeah, because I also went with that as well. But then I was sent pictures of it in the clutch with its siblings and everything matched up. And I was like, well, the fuck if I know then? Like,
then, maybe it had a mutation that put it back.
You could have a reversion mutation.
But
that's you could also have
unlikely.
Super unlikely, but you
could have an allelic dropout where basically
but then the sequencing, I guess that could be because then it would look like a, let's see. So if you had one, you could do that. It could be a little dropout.
Yeah, allelic dropout would do it. But
because unless you're doing some kind of copy number test, you wouldn't know if you only have 1 copy.
Yeah, man, it's weird. Will's hella heat. Does Lav have 2 alleles as well? Every mutation has 2 alleles. So
no, he means so.
Like
further on the conversation, there's Ultramel A, Ultramel B talk.
I got you. Okay.
There are 2 different. There are 2 different mutations that cause Ultramel. There are also 2 different mutations that cause albino, and I'm not talking about candy or toffee. Well, there's 3. Yeah, I'm not talking about candy. I'm just talking about strict albino.
I got you.
There are 2 mutations that cause that, and there are 2 that cause yellow belly. Different mutations, identical phenotype. With Lav, it's all 1 mutation. Now,
it's a deletion.
Maybe somewhere out there's another allele that hasn't been sequenced yet because it's a low frequency or it's a newly imported one. Like I know there are other lavender type animals that have come in the past. Those may be independent. My guess is that they're just Lav genes that are turning up out of the farms in Africa. When I say the farms, I mean the captive bred collection of those animals, kind of the way that butter got sold as butter when it was really lesser because it was just the same gene sold as a different way to somebody else.
Right.
Way back in the dark ages. So odds are it's a single allele or a single gene.
Did y'all already cover Ultramel A and B, I assume, while I disappeared for a moment?
Well, I covered it just in the chat.
Okay.
That there are two alleles for it. Both of them are visual. A Ultramel A to Ultramel B gives you completely visual animals. There's no difference in their phenotypes.
Interesting.
Same with the yellow belly -1 and the yellow belly -17. They look the same.
Yeah, and those 2 albino ones that are the same.
Yeah, it's crazy.
And we see this in other animals too. In mice, there are 17 different mutations that cause the albino phenotype.
I was going to say albinism.
Yeah. In zebrafish, there are I think a half dozen or so. It's not unusual to see multiple mutations for genes like this.
Yeah, this kind of goes back to none of this is actually simple, right? There's lots of things that regulate these phenotypes, and so you can end up with with albinism, right? It's a complicated pathway to get to that final phenotype, and so it's not surprising that disrupting it along the path at different points can lead to a similar phenotype. yeah, no, this is all an adventure and it's all relatively new. Like you said, Ben, like we are sprinting to a whole new world with the amount of mutations that we can now detect and how testing is going. Yeah, it's an adventure. So I'm looking forward to seeing how things go. Not just with RGI, also, just to be fair to like, there's multiple companies now that are popping up, which I think, in the same way I've said this about Morph Market, I think competition is good in general. If nothing else, it lights a fire into people's ass, which is always a positive. I know the owners of the companies hate that, but I think from a consumer side, it's a good thing.
See, I went around at shows for several years handing out flyers about, testing that we could do, which was just the Kluber test, and then other things that we could do, we could design, and nobody wanted to talk to me about it. So the fact that there's other companies now that want to do it as well is great.
I think,
I talked to you about sex testing way early on. I mean, yes. I used you for a lot of stuff to make sure that I knew what was going on.
You are one of the few nerds that believed early on, and you very well could have been thinking about it before I did.
Oh, I was thinking about morph tests way the hell long ago. Like I brought it up on BLBC like a decade or more ago, and I was like, hey guys, what do you think about genetic testing for hets? And on there, basically everybody was like, that's the dumbest thing I ever heard of. Nobody would pay for that. And now I'm just like, motherfuckers.
Yeah. It's funny.
Sorry, Patrick. I hope I'm okay to swear.
You're fine. My junior year in undergrad, I actually got a quote to do genetic testing. Like I was trying to get a sequencing quote because I was like, no, this could be a thing. And then they come back, and at the time, right, like sequencing was obscenely expensive, and they're like, for like $80,000, we get your project going. And I'm like, what do you mean going? And they're like, well, that's just the start. Like we don't really know. I'm like, oh fuck, I'm out. And of course, this is still in the heyday of codoms and all of that stuff. And honestly, Travis, to your point, I actually think the maturity and the evolution of the industry as a whole, moving towards recessive stuff, is why people care now, right? Because if you think when BLBC was around, it was the codom heyday, right? All we cared about was that shit.
A bit it was, but also the reason I brought it up because that was also the heyday of the bullshit hets and the fake hets. People were selling things as het that worked. People were selling their animals with like notarized pieces of paper, notified breeding records that was like, I guarantee this animal is a het. This is the male. This is the female. I got this notarized to prove that it was a het. So, I'm not ripping you off. Nobody does that now.
Red flag.
But this was back then because, there were so many people that were pulling that scam.
Yeah.
And I was thinking, this would be great for people because now you don't have to worry about people scamming you. You just, here, look, I've got the genetic test. It shows that it's het albino. Go breed your albinos.
But even further, like I feel like I've said from the very beginning, I don't think this matters from a selling standpoint because I could still be lying to you, right? Oh, I genetic tested this animal. You can trust me. I thought the power is for the buyer and the breeder, right? The breeder for holding stuff back because I trust myself.
Oh, yeah.
And the buyer, once they get an animal, they can test it and they know that shed came from the animal they bought because they're testing it themselves. So that was always the power for me because people are like, well, how's this going to help me sell an animal? I'm like, I don't know if it's really going to per se help you to sell an animal because I still don't trust people. But when I buy an animal or you buy an animal from me, you can test it and you can double check me. And that's a huge relief. And also, I mean, think about, without naming breeders, like there were breeders that were dumping fake hets into the industry for years, and you don't find out for 3-5 years because it takes that long for stuff to breed out. And now we can, just recently we had a breeder who sold a whole bunch of fake stuff.
Yep.
And
they used our testing to prove that he was full of shit.
Well, yeah, it's a sad day, but like that was it, right? Like you run through the testing real quick, and within a couple of months, you can have a really good idea of whether or not, it's actually het. So I think those are the really big benefits in the maturity of the market as a whole. It's been a big, I think overall it's been a big net positive. I see the negative side where we are flying to endpoint projects because now we're testing, so we're not having to worry about posets and stuff. And I get where that's going, but Who is the breeder? Is it public knowledge now or not? Yeah, it was Daniel Allison. It's okay. I'll say it out loud. It makes me really sad. Daniel was one of the most welcoming people that I knew in the industry, and I've known Daniel for a long time. Daniel has some personal issues that have caused him to go up and down in this industry since I've been in it. And unfortunately, he was at a low point and made some very, very, very unethical decisions. And it makes me sad. But fortunately, we were able to test stuff. And all of my assumptions when he reached out to me to try and sell me the animals were confirmed without me having to buy them. I felt too good to be true, unfortunately. But yeah, you don't really need to worry, Will. You don't need to worry about Daniel. He is not really in the industry anymore. He has no sales outlets, or he's kind of been terminated, more or less.
From what I've heard, he is still trying to sell some things, but he doesn't have like a
he has no he has no platform at this point, right? So if he somehow finds you and you buy something from him, it's kind of on you at this point. Like, you've gone into some dark Craigslist alleyways to get there, and you know what? If you're buying a hypopie desert ghost animal off Craigslist, you're just asking for it to not be a desert ghost. So, yeah. Let's see. Daniel was very good to me in the early years. It's true. Yeah, 100%. He was very great. He has some demons. So, all right, guys, it's been an hour and a half. I've wasted enough of y'all's time. So
not a waste. I've enjoyed it.
Awesome, man. I'm glad to hear it. I hope there's some more clarity here with Desert Ghost. I will once all the data is out, Ben, I'm going to be doing another one of these, and maybe in a couple of months we can all circle back and go over the math and talk about it a little more in depth and see what we actually think. But I'm excited for that data to really come out and we can actually have some real science about it.
Yeah.
I think I know the answer to this. None of this is ever going to be published by RGI, correct? Y'all don't plan on doing any academic portion of this, right?
I definitely would be happy to. My guess is someone else will publish it before I can get to it. My goal from the beginning as a breeder was because I worked as a PhD student in food animal species like cows and stuff like that, horses, pigs. I saw, how much of a huge benefit, and really for livestock breeders, ranchers and stuff, for them to stay viable, they have to do genetic testing. Like, there's no way they can compete unless they do genetic testing. Like, they would 100% go out of business very quickly if they didn't. So to me, it killed me inside to see all of this for everything else, but zero for reptiles. And I know every year that goes by, there's more and more captive breeding of reptile species. And so for me, I was in a pharmaceutical job that was very safe, good pay. But it just killed me every year. For 10 years, I was doing this nights and weekends, thinking about it and designing things and trying things. And, but it just killed me knowing, that we could do this, we could make it happen. And so that's still how I feel. I want to make a bunch of tests available for breeders. I'm much less worried about academics right now, but 100%, like 3 years from now, if most of the things that reptile breeders need are done, and I have people that are doing most of the sample prep and, reporting, all that stuff. I'm just designing new stuff and I have time to write. Yeah, I'll happily write up, that would be great. I would enjoy that. But my guess is other groups will publish it before I'll get to it.
I think it's actually cool. For those who don't know, the only gene as of now that we can definitively 100% without issue say is truly causative is pied, right? That's the only one that's actually been put back into another animal.
Yes.
Even then,
it did weird things when we put pied back into another animal.
Yeah, someone could be a pain in the butt and say, "Oh, but it doesn't look like a pied ball python,"
It's not going to. I agree with you. It's not going to. I think it's as good as it's going to get realistically, right?
It definitely convinces me.
Yeah. Oh, what somebody said? Show the other leg next show, Patrick. Oh, is my leg? It is all about. Y'all like that? Is that good? Is that y'all want my leg? There you go. I can bring Batman in here too, guys. Look, this is my casting couch. Enjoy it. So I'm excited. I know the Canadian group has talked about doing similar stuff with other genes and things like that. So you know, it'd be interesting. I think they will probably beat y'all to the publication side of stuff.
Oh yeah.
But they
I
also,
sure hope so.
yeah, I mean, they're an academic group, right? You may not know the answer to this. You may not be able to say their Desert Ghost site. Have y'all talked about if it's this? Have y'all compared notes? And is it the same mutation that they're seeing?
I've offered to share our low pass whole genome data on DG samples and trade it for theirs so that they can see everything and we can see everything. And they said they needed to talk about it. So we'll see. Maybe they're not interested. They want to just roll with what they have into their publication, and that's a little cleaner. And, you know, whatever they want to do, I would love to see everything, but, you know, eventually they'll publish it. Well, I guess they might not publish their whole genome stuff, but or they might not.
But they'll probably deposit it.
Yeah, I mean,
if they do, that'd be great. And if they do that, you know, once I'm able to see theirs, I would be happy to give them ours and let them see what we're seeing too. Doesn't bother me.
I think it'll be good. I'm excited. I mean, obviously from the, you know, standpoint of being able to look at this stuff and validate it myself and mess with it, I appreciate the publications because I can take the stuff and, you know, actually on my own things, validate stuff. So it'll be good. As we finish up real fast, somebody just said, so can animals just test for DGC and be negative for A and B? We'll find out. That's the answer, I think, at this point. Once Ben starts posting the data,
you'll be able to see
actually go through. Yeah, we'll be able to look through. And like I keep saying, like we'll do an episode where we go over that data specifically, and y'all can live the life that I do every day when I do number crunching for human samples.
And it's awesome. So many.
Man, Sean keeps pushing that button right at those opportune times.
You'll be able to look at the picture yourself, decide if it's visual or not, and then, you know, look at the results. So I think
it'll be good. I think it's gonna be really good. All right, guys. Travis, Ben, Dr. Travis, and Dr. Ben. Thank you all for coming on and hanging out for an hour and a half or so. We're definitely gonna do this again. And we will not talk Desert Ghost next time. Well, we'll talk about it one more time, and then the third time we all come on, we're not going to talk about Desert Ghost at all because we're going to be all burned out on it. I hope this gave some more clarity to Desert Ghost stuff. I know that Ben has probably said 99% of this in his lives. Y'all should all go watch those and get educated. And if you haven't watched it, well, go watch it. Travis, where's the best people to get a hold of you or to follow you or to do stuff with you?
Well, you can find me on Facebook, Travis Wyman. I'm not the motocross racer, so don't try to friend him or message him because he's not going to know what the hell you're talking about.
Okay.
You can message me. That's probably the easiest way to get a hold of me. You can also email me, asplundii@gmail. And you can find me on Instagram, snakes_n_bakes.
Cool. Quick side note. Travis bakes a lot of food and his pictures always look delicious. And I'm spectacularly jealous of your coworkers because no one cooks for me at my job. Andre cooks nothing for me. I'm very bitter about that. So y'all should go follow him and be super jealous of his coworkers. Ben, best place for people to find you.
The YouTube is Rare Genetics Weekly is our weekly show. And then Facebook, Instagram, and our website, you know, that's all Rare Genetics Inc. So that's the best way to find us.
Sweet, man. All right, guys. Thanks again. Travis and Ben, if y'all want to stick around for a second, I'm going to hit the outro and then we can chat once we end the stream. So everybody else, we'll see you Thursday for Late to the Mic. Chase and Troy and I are going to act like asshats as normal and have a good time. So come join us Thursday night at 10 p.m. Eastern, and we'll have a good time, guys. Everybody else, bye.